This is the fourth tutorial video on Year 13 or Level 3 probability distributions. So this one we're looking at combinations of random variables. So in the picture you can see we've got two buckets. Now in each of these buckets we expect there to be 10 litres of water, which is 10,000 mils. Now our variance, it could vary. It could vary 50 mils, it could be 50 mils less, it could be 50 mils more. So variance of 50 mils when we're measuring it in there. And we've got a second bucket here. The second bucket has the same expected value and the same variance. So if we go and combine and we have the expected value of bucket 1 plus bucket 2, well, the expected value is pretty obvious, isn't it? We're expecting to have 10 litres plus 10 litres. So we're expecting to have 20 litres or 20,000 millilitres. Now, if we add them together, well, bucket 1 might have had 10 mils, not enough. Bucket 2 might have had 50 mils, not enough. So we could, in fact, have a variance of 50 plus 50, a variance now of 100 mils. Makes sense? 100 mils. Okay, so our variances are added. It could have been 50 mils not enough and 50 mils not enough, 100 mils not enough, or 50 mils more, 50 mils more. Okay, so what if we had a bucket and a jug? Let's try and get rid of this. Okay, bucket, we still expect there to be 10 litres or 10,000 mils, and the variance stays the same at 50 mils. But we've got a 1 litre jug here now, and the 1 litre jug, of course, we expect to be 1 litre, and a variance of the jug of 5 mils. So what would we expect? So our expected value of bucket 1 plus jug 1 would be 10 litres plus 1 litre, and we expect there to be 11 litres, or 11,000 millilitres. Okay, so the variance, if we're adding them together, we expect, well, the jug may have 50 mils too much. The jug might have 5 mils too much, so now our variance is 55 mils. Righty-ho, so, but what about if we're subtracting? Expected value easy. Expected value of the bucket minus the jug, well, 10 litres, and if we take out a litre, we expect it to be 9 litres, or 9,000 millilitres. But I want to show you that the variance is still added. So the bucket might have actually had 50 mils more. And then when we scoop the litre of water out, we might have had, the jug might have its 5 mils not enough. So instead of taking out 1,000 mils, it might only take out 995. Now if it takes out 995, you can see it's taking out 5 mils not enough, but there were already 50 mils too much. So our variance is still added. It is the variance of the bucket plus the variance of the jug. So the variance becomes 50 plus 5, 55. And the same thing would happen if the bucket had 50 mils not enough, so we're 50 mils down, the jug takes out 50 mils, 5 mils too much, so we're 55 mils down. Either way, our variances get added. Okay, so you can see that on the formula sheet that expected values of x1 plus x2 plus x3 is equal to the expected value of x1 plus the expected value of x2 plus the expected value of x3 etc. And the variance of x1 plus x2 plus x3 is equal to the variance of x1 plus the variance of x2, etc. Okay, so that's the end of this tutorial. We're going to look at some binomial and some Poisson distributions using discrete data in the next couple of tutorials.